Path of the Pole by Charles Hapgood, Part 4. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents. This is Brothers of the Serpent podcast, and we are coming to you not live from the 10 by 10 by 10 Tangent Cube of Science, where we are nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau. Kyle is back from the beach. We're both back in the cube.
What's up?
How was your fishing trip, buddy?
Oh, it was great.
Yeah?
Lots of beers on the beach. Finally caught some fish on the last day. It was awesome.
Yeah? Did you actually get a vacation? Like, was it a vacation?
Yeah.
Okay.
Yeah, it was like...
It's not a working vacation?
Yeah, it wasn't working. I mean, fishing is work.
Yeah.
So, yeah, it was a lot of work, but it was awesome.
Yeah. I mean, breakfast beers sounds like...
Breakfast beers was great.
Sounds like vacation to me.
Yeah. I wore myself out a number of times, but then I would just take a nap on the beach.
So that's the key. If you can take a nap whenever you want, it's a vacation.
Yeah. Even if you don't.
Yeah, even if you don't do it. That's right. That's right. Our timer's not going.
And it was genius, too. We came back on Friday, so we had the whole weekend to just, like, chill.
Yeah.
Because, I slept a lot yesterday. Because I did not sleep a lot.
At the beach, sure. Yeah.
Up early in the morning, going fishing.
Yeah.
And staying up late drinking. Hanging out.
Right. Well, that's standard vacation, right?
Yeah. Yeah. It was great.
Cool.
So, back to the daily grind.
Yeah. Back into the book report.
Yes.
So far, we've been averaging one chapter per episode. So hopefully we can move through more of the book than that moving forward. Otherwise, this is going to be a very massive book report.
I feel like the book reports just keep getting longer.
Probably.
Just because something.
For some reason.
For some reason.
Yeah. Well, I also think I'm reading slower and slower.
Yeah, okay. Yeah. Which is better.
Yeah. Yeah. If you listen to the older episodes, I used to read way too fast.
Dude, who cares if they're long?
Yeah.
It's just content.
Right. Yeah.
You don't like the book, come back in 2 months.
Right. That's right. There you go. So we are moving into chapter 4 of Path of the Pole this week. And this chapter has a bunch of charts and sample data or whatever that I'm going to have to work through. But hopefully it'll be understandable. But I think there's a lot of good stuff in this chapter.
My God.
Yeah.
Is there any stuff that's not highlighted?
The pictures aren't highlighted. But yeah, no, a lot of this I'm like, I go through and I'll say, well, I can take that out. And then I realize later that I want to read this part, but I have to have that other information to do it. So this happens with this book so far. But yeah, I am skipping more stuff as we move forward. Okay, so chapter 4, evidence for the North Pole in Hudson Bay. In the preceding chapters, much evidence has been presented to support the assumption of the displacement of the Earth's outer shells over the inner body. Displacements that may have occurred rather frequently during the history of the Earth. It is now time to tie down this assumption with concrete evidence that such a displacement has occurred, not in the remote past of the planet's history, but in very recent time. And not once, but at least 3 times in that recent epoch that we call the Pleistocene. Several lines of solid evidence suggest that during the last ice age, the North Pole was located in or near Hudson Bay. The reader will understand that if this was the case, it was the result not of a change of axis of the Earth, but merely of a shift in the position of the crust or lithosphere relative to the Earth's inner layers. It seems desirable to have a definite point of reference rather than a vague general area to postulate as the position of the pole during the last ice age. From an examination of all the evidence, which will be discussed in the following pages, the best guess for the site of the pole seems to be approximately 60 degrees north latitude and 83 degrees west longitude. We will find this definite assumption useful when we consider specific corroborating evidence from various other parts of the Earth. Part 1. Remarkable features of the last North American ice cap. The first line of evidence that the last North American ice cap was a polar ice cap is based on the shape, size, and peculiar geographical location of the ice sheet. Two geologists, Kelly and Dashiell, have pointed out that the area occupied by the ice was similar both in shape and size to the present Arctic Circle. Many others have remarked on its unnatural location. It seems to have occupied the northeastern rather than the northern half of the continent. No one has explained why the ice cap, which extended southward as far as Ohio, did not cover some of the northern islands of the Canadian Arctic archipelago, islands lying between Hudson Bay and the pole, or why it failed to cover the Yukon district of Canada or the northern part of Greenland. Later, we shall examine a considerable amount of evidence indicating that the Arctic Ocean itself was warm during the Ice Age. Another important problem that has long vexed geologists, and for which no solution has so far even been suggested, is the distribution of the ice of the last American ice cap, usually referred to by geologists as the Wisconsin ice sheet.
I thought the Wisconsin was in Europe.
Well, I think, well...
No, that's not right.
No, it is the Wisconsin glaciation. So it's
Wisconsin glaciation.
Yeah.
What's the European one? Because the ones in North America are...
The Laurentide and the Cordilleran, but
Yeah.
this is like this is a time period.
The time period. Okay.
Yeah.
Yeah, I'm down. Wisconsin. Definitely not in Europe.
That's right.
There
could be a Wisconsin in Europe somewhere.
could be. I just can't remember what the name of the...
I don't know.
I'll look it up.
It sounds like maybe an Indian name. So the ice appears to have been thicker and to have extended farther south on the low central plains of the Mississippi Valley, where it invaded Wisconsin and Ohio, than on the high mountain areas in the same latitudes farther west. This contradicts the basic assumption of current glacial theory, which states that the Ice Age involved a general lowering of world temperatures with no change in the position of the pole. If the accepted geological theory is correct, the ice should have formed first on the high mountains, and it should have extended farther south on the mountainous highlands than on the lower central plains. This unsolved problem may have been one of many that led one of America's foremost geologists, Professor Reginald A. Daly of Harvard, to say that, quote, "The Pleistocene history of North America holds 10 major mysteries for every one that has already been solved," unquote. The assumption that Hudson Bay then lay at the pole makes it possible to explain logically these hitherto unsolved problems. With that location, the northernmost Arctic islands would have been as much as 1,000 miles south of the pole, and the same would have been true of the western highlands. It would then have been entirely natural for the ice to be thicker and to extend farther south on the plains nearer the pole. Furthermore, this assumption also explains why the European ice sheet was thinner than the North American ice sheet and did not extend as far south. Another line of direct evidence that the Wisconsin ice sheet was a polar ice cap has been developed by the geologist Lawrence Dillon, who has examined the temperature requirements for the growth of ice sheets and compared them with average temperatures known to have prevailed around the glaciated area of North America and farther south during the Ice Age. Dillon found that the essential condition governing the growth of an ice sheet is not the average year-round temperature nor the average snowfall, but the average temperature during the summer. He points out that no ice sheets form at the present time in areas with average summer temperatures of 45 degrees or higher, and suggests that this situation must also have been true in the past. He cites as a good illustration of this the northeastern section of Siberia, which has no ice sheet, despite the fact that its average annual temperature is lower than that of the North Pole itself. Furthermore, northeastern Siberia has a higher average precipitation than either glaciated Greenland or Antarctica. But, as he points out, the summer temperature in Siberia is high, and this, he thinks, is the controlling factor. I think this is really interesting. You know, it's sort of maybe counterintuitive until you, well, it seems initially counterintuitive until you think about it a bit. But yeah, it's the summer temperatures that control thicknesses or the ability to grow like glacial ice in the first place.
Because they're the ones that are like evaporating the water.
And, well, in this particular case, this is what causes the ice to melt. So if the temperature of any given area in the summer is above the average temperature is above 45 degrees, the ice just can't build up because it just melts off each year. But yeah, I do think, that's what he says here. He says, the essential condition governing the growth of an ice sheet is not the average annual temperature, nor the average snowfall, but the average temperature during the summer.
Okay. Man.
Now, according to Dillon, the existence of the Wisconsin continental ice sheet would have required a decrease of 25 degrees centigrade in the average summer temperatures as they exist now. But the evidence is that in areas at a distance from the borders of the ice sheet, there was no such fall in temperature. He quotes evidence produced by the geologist Antarctic to the effect that, on the contrary, the average summer temperature along the 105th meridian in southern Colorado and northern New Mexico during the Ice Age was only 10 degrees Fahrenheit lower than it is now, while in the equatorial Andes, it was only 5 or 6 degrees Fahrenheit lower. So that's not enough to meet the requirements of 25 degrees centigrade lower. The assumption that that Hudson Bay lay at the pole can explain why the apparent average fall in summer temperature should have been greatest along the southern boundary of the ice sheet, then less in New Mexico, and the least in the equatorial Andes. According to our assumption, the equatorial Andes would, during the Ice Age, have been located approximately 20 degrees of latitude to the north of the equator, but still in the tropics. And so it is to be expected that the average temperature would have been only slightly lower than now. On the other hand, Ohio, then presumably on the Arctic Circle, would have been very much colder than at present. Dillon considers the situation that would have prevailed in the United States if, during the Ice Age, world temperatures had fallen about 10 degrees Fahrenheit, as some have supposed, and as might have been deduced from the findings of Antarctic in Colorado and New Mexico. By that assumption, the average July temperature around the edges of the ice sheet would have been 60 degrees Fahrenheit, as compared with 70 degrees now. This would be similar to the average summer temperature in England, northern Germany, or the state of Maine. But Dillon concludes, quote, "Since no glaciers or permanent snowfields are known to exist today in such mild climates, it seems hardly likely that they could have done so in former times," unquote. So Dillon does not explicitly suggest a polar change, but he seems to leave no alternative.
So, sorry, I had some distractions happening, but I guess it is the argument that, like he was talking about the Andes, since they're south of the equator, right?
Yeah.
So if you shifted the crust northward so that Hudson Bay was at the North Pole, then the Andes only move across the equator and they're still only at like 20 degrees. So their climate would be roughly the same. Yeah. As it seems to show in the data. But places like Ohio that would have moved up to the Arctic Circle are going to be way colder. So the standard model is trying to describe a situation where freezing cold temperatures are coming down as low as Ohio and building up glaciers there. Yeah. While the Andes haven't changed in temperature. So it's like,
or very little. Yeah. The Andes average temperature. Yeah. So, well, let's think about this. The Andes during the Hudson, if the Hudson Bay was a pole, the Andes would have been further south, closer to the southern pole. So they would have been a little bit colder, but with the shift, right? Isn't that right? No, you're right. No, that's totally wrong. They would have been further north. Yeah. Yeah. Okay. So I got that backwards. So they would have been further north, and then they shifted southward. So they would have gotten a little cooler.
Oh, yeah. Because I'm thinking of going in reverse, like shifting it north.
Yeah, let me back up to that spot
So,
where he's talking about that.
I'm just trying to piece this together in the sense that the standard model is trying to describe a world in which the global average temperature dropped enough to form these massive ice sheets. Whereas what his model is suggesting is that you're just shifting the crust. The global average temperature basically stays the same.
Yeah.
It shifts a little bit because you move ice out of the Arctic Circle.
Yeah.
And you're moving a warm area into the Arctic Circle, which begins to rapidly cool.
Yeah.
The ice that was moved out has to melt, which is going to cause all kinds of climatic changes.
Yep.
So there is going to be a shift, but it seems like it's not great enough to say, well, everything stayed in its same position, but the Earth was so much colder that ice grew down as far south as Ohio, which is what?
He's checking the map.
Just look at it's like 45 degrees at least. Yeah.
Yeah, so yes, and the problem with that idea that the whole planet basically got
Between 30 and 45 degrees north latitude.
yeah, so the explanation that the whole planet got a little bit like cold enough to make ice grow as far south as Ohio, then you have to explain why wasn't there ice in the Yukon, in Alaska, in Siberia,
Yeah.
right? Because if you're able to drop places like Ohio cold enough to where you can have massive ice buildup there, why didn't those other places that are already very close to having glacial conditions, why didn't they grow ice?
Yeah, this square map is not very good for this idea.
Yeah,
because you're
yeah.
trying to like slide this crust around on this square map.
Yeah, we need a globe in here.
I need to go get the globe. I've got one. I'll get it during the break.
So let's see, where was the Andes stuff? I'll find it here.
Yeah, so I'm just thinking that I think that the argument that he's making is that like you don't need to have these massive global climate shifts. You just need to have the crust move, and that explains why there's ice in places where it shouldn't be. Because once it moves up into the poles, it builds an ice sheet.
Yeah. Okay, so he's specifically talking about the equatorial Andes. So you basically can say that. So they're on the equator. So he's saying that during the Ice Age, they would have been 20 degrees of latitude to the north of the equator, but still in the tropics.
Right.
So their average temperature would have only been slightly lower than now. On the other hand, Ohio would have been in the Arctic Circle.
Right.
And then like I said, he finishes it with, Dylan does not explicitly suggest a polar change, but he seems to leave no alternative. So yeah, I think all Hapgood is trying to point out here is that the strange evidence of if you look at different average temperatures and everything of places around the world during the Ice Age, it isn't well explained as a general global drop in temperature. It's better explained as just that I've been trying to think of a way to say this, that the seasons and the temperatures themselves as they sit on the Earth as a globe, as just a sphere, don't change, but you just rotate the skin, and then you put the cold places in different areas.
Right.
And then he also talks about, and I think we'll get to this later, he talks about how there's a big difference in what happens to ice when it's building up on land as opposed to water.
Yeah.
And you can end up on land, you end up with a much larger ice sheet, and that causes an albedo change and resulting winds that can carry extremely cold temperatures farther away. Right. Okay, so part 2, the warm Arctic of the Ice Age. One of the necessary corollaries of our assumption regarding the site of the North Pole during the period of the Wisconsin ice sheet would be that the point now at the North Pole, in the middle of the Arctic Ocean, would then have been 30 degrees away from, that is, south of, the pole, and could have been expected to have climatic conditions similar to those of Hudson Bay now, while the coast of Siberia, on the opposite side of the Arctic Ocean, would have been enjoying a warm, temperate climate. Does the evidence support this? I think it does. I've already mentioned that some of the islands in the Arctic Ocean were never covered by ice during the last ice age, a fact that has been long known. The first of our radiocarbon dates below relates to comparatively warm conditions on Baffin Island in the far north, 15 degrees or about 900 miles from the pole. Okay, so there's a bunch of sample data here. So number one, sample from the Isortok River on Baffin Island. And he has a quotation, alder and birch remains in peat suggest a slightly warmer climate than today. Taken in conjunction with leafy peat taken from the same site, there is a strong implication that during the period of 24,000 to 30,000 years before present, the large proportion of north-central Baffin Island was ice-free, or at least carried less glacier ice than it does today. So it's important to note that a climate on Baffin Island warmer than today existed just when the Wisconsin Continental Glacier was going through a vast expansion. The temperate character of the sea around Baffin Island is indicated by another date. Sample 2, shells from Baffin Island. One of the species, Venericardia borealis, indicates marine conditions may have been slightly warmer than today. And still another date from Baffin Island suggests that the warm conditions lasted through much, if not all, of the period of the Wisconsin glaciation. Sample 3, shells from Steensby Inlet. These are dated at 19,000 plus or minus 1,000 years before present. Date possibly indicates a period of open water at Fox Basin at circa 19,000 years before present. As about as far north, but to the west, we come to Banks Island in the Northwest Territories, on which no evidence of glaciation has ever been found. Sample 4, evidence for existence of Wisconsin refugium on unglaciated islands of West Arctic archipelago is inconclusive, but the date tends to substantiate existence of refugium. So a refugium is a place where it's just what they call a place where plants and animals can survive.
Yeah, refuge.
Yeah, during adverse conditions elsewhere. Thus, it seems that during the Wisconsin Ice Age, there was a temperate climate refuge in the middle of the Arctic Ocean for the fauna and flora that could not exist in Canada or the United States. There is no suggestion that this refugium was limited to Banks Island. So we must acknowledge that the absence of glaciation on these islands does not make sense, according to the theory that the glacial period was the consequence of a worldwide lowering of temperature.
That's what I'm getting at, yeah.
If the pole had then been in its present position, the weather could not have been warmer on Banks Island than it is in Ohio.
Yes. Yes.
So J.B. Dallaire has sent me an interesting passage from an old geological book entitled Geology of Weymouth, Portland, and the Coast of Dorset, England, by Robert Damon, published in 1860. Damon refers to Sir Robert McClure's narrative of the discovery of the Northwest Passage. McClure mentions the existence of a fossil forest on Banks Island, where, for a depth of 40 feet, a cliff was composed of one mass of fossil trees. Quote, 120 miles further north, we discovered a similar kind of fossil forest, unquote. And as we shall see, such fossil forests have been found not only in the Canadian Arctic archipelago, but all along the coast of Siberia. So we go now farther north to Axel Heiberg Island, only 9 degrees from the pole.
I wonder if that suggests like serious volcanism during the shifting. Like if it just buried a forest in ash.
Yeah.
Like Pompeii style?
Yeah.
And just are the trees standing or are they all clumped up? Like,
Yeah,
floods and what, I don't know.
Like 40 feet of fossil trees.
Yeah, that's what I'm saying.
Yeah.
40 foot, I don't know. I'm envisioning them standing
Are they all
up.
standing?
Yeah. Like if a Pompeii type of thing happened to a forest,
Yeah.
it's not like it blew in and knocked people down. It just buried them in ashes.
Yeah.
And they're soft.
Right. Yeah, could be. Man, that would be cool to see. But that kind of reminds me of when we went to see the fossil,
Yeah.
the petrified forest in Arizona. People were like, "Where are the trees?" And I'm like, "Guys, they're not standing.
They're rocks.
They're rocks laying on the ground." Oh, they're all looking out into the desert for trees. Okay, so fifth sample he gives here. These are shells of warm shells of warm climate species. So these shells appear to extend the warm period in the Arctic back to about 40,000 years ago, and a second sample from the same island supports the same conclusion. Other samples show that the warm climatic conditions extended right down to the end of the glacial period, and that down to 8,000 years ago, Melville Island and Lockheed Island in the Northwest Territories had never been glaciated. Thus, we are able to say that warm conditions in the Arctic archipelago of Canada persisted for the entire duration of the Wisconsin glaciation, from 40,000 years ago down to the establishment of the modern conditions. But we have not finished. We must get closer to the pole. We can accomplish this by examining the results of a number of sea cores taken from the middle of the Arctic Ocean. The Lamont Geological Observatory of Columbia University obtained these cores in order to explore the ancient climatic conditions of that ocean. Sample 6. Foraminifera separated from 4 cores, all from latitude 84 degrees north. In each case, the sample represents the base of zone rich in forams. The base of the foram-rich zone apparently does not correspond to the end of the Wisconsin, but to some much earlier event. So this comment reflects the view that the foraminifera are evidence of warm climate prevailing in the Arctic Ocean about 25,000 years ago. So it is worth noting that they come from the deep sea and within 6 degrees of the pole itself. This seems to rule out the possibility that local conditions could have influenced matters. It is evidence that the Arctic Ocean was temperate at that time, which, as the reader will have noticed, is precisely the time of a great advance of the Wisconsin Continental Glacier in the United States, 3,000 miles to the south. So at the same time that these foraminifera, these animals, are showing evidence of basically a temperate temperature of of what is now the Arctic Sea, less than 6 degrees from the pole, the Wisconsin glaciation over Canada and North America was going through a massive expansion. So these two things don't match up if you're trying to control the ice with global temperature changes.
Yeah. Yeah.
Okay. The fact that the temperate conditions in the Arctic Ocean were general becomes evident when we examine evidences from the opposite shore of the ocean along the coast of Siberia. Here, as we might expect from the fact that we are getting farther and farther away from our pole in Hudson Bay, the evidence of warm climate during the North American Ice Age grows stronger still. The following dates establish the warm temperate characteristics of the climate in a vast territory, which is now very cold. So he has a table here of radiocarbon samples from Siberia, and they are ranging in dates from, 42,800 years before present to 26,000 years before present. Mammoth hair, wood from trees. Anyway, other flora and fauna examples.
What is this? So the on Wikipedia, it says the Wisconsin glaciation extended from approximately 75,000 to 11,000 years ago.
Yeah. Yeah, but it went through multiple expansion and retraction events during that time as well. So at the 25,000 years before present, it was going through
The
an
last
expansion
glacial
event.
maximum.
Yeah.
That's the 25,000 to 21 years ago.
21,000 years ago.
Yeah, 21,000 years ago. Sorry.
Wait, it ended 21 years ago? Okay, so he says here, so this is incontrovertible evidence of warm climates in the Yenisei River Valley when the mammoths lived there. This area above the Arctic Circle, then evidently forested, is now a barren tundra. So in summary, I think I can reasonably claim, with regard to this table and the preceding dates from the Arctic Ocean and Arctic Canada, that they confirm an important corollary for the pole in Hudson Bay. Yes, if the pole were in Hudson Bay, the Arctic should be warm, and the Arctic was warm. However, there is much more evidence.
Cool.
Yeah, and we'll get into that evidence in part 3 after the break.
All right.
Take a quick break.
I promise not to get distracted anymore. Here on Brothers of the Serpent podcast, trying to look up too many things, and I need to put the phone down and stop doing it.
Or just say what you're distracted
No, because if I say something, it'll be stupid.
Oh.
I'm trying to prevent that as well. Already screwed that up once or more. So I'll just drink this beer and try to learn.
Yeah, no watcher today, by the way.
Yeah,
I'll
that's
just
really
say that.
screwing me up.
Yeah.
Thanks.
Watcher helps.
I can blame it on the watcher.
Yeah. Sometimes the watcher can't join us. He's too busy in space.
Yep.
You know. Okay, so we're now part 3, the Soviet evidence of the warm Arctic. In recent years, Soviet scientists have been very busy surveying the Arctic Ocean, in which they have a rather proprietary interest, seeing that most of its coasts belong to them. They have examined a great many cores from the ocean bottom and have dated them by the new methods of radio elements. They have come to the conclusion, just as we have, that the Arctic Ocean was warm during most of the Ice Age, particularly from about 32,000 to about 18,000 years ago. A report by the academicians, how do you say that word? Academicians? Academics, Sachs, Belov, and Lapina, covering many phases of their oceanographic work lists the successive climatic changes in the Arctic as follows. Okay, so 1, down to 50,000 years ago, the Arctic was cold. 2, from 50,000 to 45,000 years ago, the Arctic Ocean water was warm. 3, from 45,000 to about 28 to 32,000 years ago, it was cold again. 4, from 28 to 32,000 years ago to 18 to 20,000 years ago, it was warm. 5, from 18 to 20,000 years ago to 9 to 10,000 years ago, it was cold. And about 9 to 10,000 years ago, the present climate was established. So you see there's like multiple shifts there. Sachs, Belov, and Lapina have theories by which they explain these changes. These theories, while they do not agree with ours, may still interest the reader. They assume that the pole during this whole period was where it is now, and that consequently the Atlantic Ocean was temperate for the most part, though colder than now, especially in the higher latitudes. They correlate the warm periods in the Arctic Ocean with times when the warmer Atlantic waters could freely enter that basin, and cold periods with times when the circulation between the two oceans was cut off, possibly by a land bridge across the North Atlantic connecting Greenland, Iceland, and Scandinavia.
A land bridge.
Yes. This land bridge could not have resulted from a lowering of sea level due to the expansion of glaciers, for this would have amounted to only 300 feet at the most. Well, I think it's now thought to be 400, maybe more. It would have required an uplift of the sea bottom. The Soviet scientists cannot explain why or how the sea bottom could have risen, but never mind, the hypothesis is necessary to explain the facts. I work in the same way, but with a different hypothesis. Although my hypothesis is different, It too will include uplifts of the ocean bottom to explain some of the facts of the Ice Age, but not the climatic changes. My explanation of these 6 climatic periods is as follows. 1. Down to 50,000 years ago, the western Arctic Ocean, the end toward Norway, was cold because of an earlier location of the pole, which will be discussed later. 2. From 50,000 to 45,000 years ago, the western Arctic was warm because the pole had been shifted to Hudson Bay, and warm waters from the eastern Arctic Ocean towards eastern Siberia and Alaska moved westward. 3. From about 45,000 to about 28 to 32,000 years ago, the waters were probably not cold except in certain places and at great depths where cold water had been trapped. Unfortunately, we do not yet know the latitudes and longitudes at which the Soviet cores were taken, and we do not know how the Russian scientists interpreted these cores. 4. From 28 to 32,000 years ago to 18 to 20,000 years ago, the Soviet scientists are in complete agreement with us, and this is a positive matter of great importance, in view especially of the agreement with the findings of the Lamont Oceanographic Expedition, which was already been mentioned. From 18,000 to 20,000 to 9 to 10,000 years ago, the cold period could have resulted from the movement of the pole from Hudson Bay to its present position in the middle of the Arctic Ocean. Leaving aside the disagreement about the period of 45 to 28 to 32,000 years ago, which cannot be settled without further analysis of the evidence, we are entitled to claim that the Soviet findings of a warm period in the Arctic from 28 to 32,000 years ago to 18 to 20,000 years ago are in agreement with our assumption regarding the location of the pole. The Soviet publication Sputnik, in its issue of November 1968, reported the discovery of evidence of human occupation of the new Siberian islands, as well as of Spitsbergen during the Ice Age. Both archipelagos are virtually uninhabitable now, especially the New Siberian Islands, which lie only 10 degrees or about 600 miles from the pole. Sputnik gives the source of the information as the newspaper Communist Tajikistana, and it says, archaeologists have discovered traces of a Stone Age settlement on the Novosibirsk Islands, or the New Siberian Islands. They have found bone implements and arrowheads, as well as needles and axes, skillfully fashioned from mammoth tusks.
God, that's wild, dude. Just like, I don't know. Just it's kind of Game of Thronesy. You know, you're up there near the Arctic Circle.
Yeah.
It's just covered in ice, and then you step on something, and a spear pops up with a stone tip on it. You're like, what?
Yeah.
Who could live here? Winter has come.
Yes. Spitsbergen was once inhabited too. Proof of this can be seen in the fragments of prehistoric cliff drawings found near the present-day settlement of Alaskan. On the rock face are well-preserved, incised outlines of whales and deer.
Wow.
The presence of primitive man on these islands is good evidence of warm climate in the Arctic Ocean in the Pleistocene epoch. Part 4. Evidence from Japan. Since a shift of the lithosphere would change the latitudes and therefore the climate of many countries, we must consider the evidence from as many of these as possible to see whether it agrees with our assumption. With a pole in Hudson Bay at latitude 60 degrees north and longitude 83 degrees west, Japan would have been situated about 20 degrees farther south. There should, therefore, be some evidence that the climate in Japan was definitely warmer. We do have a few radiocarbon dates that suggest the temperature during the glacial period was warmer rather than colder in Japan. One sample of wood from Ishikawa Prefecture, dated at 34,000 years ago, carries the comment, quote, "Flora suggests warm climate," unquote. Another sample of coral from Okinawa, dated 22,500 years ago, showed no signs of the glacial lowering of temperature. It was, quote, thought to be late last interglacial or early last glacial stage, but the date found falls into the period of the rapid advance of the American ice cap, unquote. So that's interesting. They're basically saying before they did the radiocarbon dating, because it indicated a warm climate in Japan, they were assuming that it was part of an interglacial. But when they did the dating, they got a date that put it at an expansion of the ice age elsewhere. Fortunately, Japan is in approximately the same latitudes as the United States, and therefore a comparison can be made between their conditions in the Ice Age. The northern Japanese island of Hokkaido is in approximately the latitude of Boston. The northern end of Honshu, the main Japanese island, is in about the latitude of New York. Tokyo is a little south of Washington, D.C., and Nagasaki in southern Japan is on about the latitude of Atlanta, Georgia. Unlike the Atlantic seaboard of the United States, Japan is highly mountainous, and the Japanese Alps compare with the other great mountain ranges of the world. They are not now glaciated, and it is interesting to note that during the Ice Age, they were only lightly glaciated. The key matter is the elevation of the snow line. How far down did the Japanese glaciers come during the last glacial period? The answer is given by Professor Kunio Kobayashi of Shinshu University. He says, the maximal expansion of glaciers in the Japan Alps took place approximately 27,000 years before present. And during this phase of glaciation, the snow line is supposed to have stood roughly at the level of 2,500 meters above sea level. From this, we learn that the maximum expansion of Japanese glaciers took place at a time roughly corresponding to the main advance of the Wisconsin continental ice sheet in America, and also that the ice did not descend farther than 2,500 meters, or about 1.5 miles above sea level. Contrast the situation in America. There, the continental ice cap came down to sea level all along the Atlantic coast as far south as New Jersey. The ice is thought to have stood 1 mile deep over New York. Surely these facts are consistent with the assumption that Japan at that time was farther south than it is now. Yeah, I think that's very interesting. Because I guess if you look at the map and you move the pole to Hudson Bay, it pushes Japan towards the equator.
Yeah. Oh, we got a note from the watcher.
Oh. What's he say?
He says, give him a couple of Minites.
Couple of Minites for the watcher. Part 5. Evidence from the coast of Mexico. According to the theory that the Ice Age was caused by some factor that cooled the whole Earth, while the poles stayed put, the Pacific coast of Mexico should reflect the fall in temperature. But, strangely enough, the indications are that the Ice Age made no difference in the temperature of the sea. The following dates tell the story. So, he's got a table of dates here from the Pacific coast. Conch shells dredged at a depth of 114 meters. And remember, all this is off Mexico. So it says the occurrence of this tropical species at 22 degrees north latitude during a low period in Pleistocene temperatures indicates that the southward displacement of the fauna there was probably not very striking at this latitude. Those are dated at 19,300 years before present. More from 37,000 years, 25,000 years, and 29,050 years before present. All of them basically give indications of warm fauna, or warm water fauna. So a better explanation of the discrepancy between the land and marine species is the following. The pole in Hudson Bay would actually be closer to California than it is now. And the continental ice cap would certainly lower the land temperature of the west coast as expected. However, this position of the pole involved a warm Siberia and a warm Arctic Ocean, and warm currents might well have flowed southward from the Bering Sea along the west coast of North America. The result would certainly have been heavier rainfall. I have here substituted one speculation for another, but I insist that this speculation is reasonable. All these dates unite to say that the sea was warm, and no other theory has so far offered itself to account for it. Part 6. Evidence from Africa. There are a number of radiocarbon dates from South Africa, northern Rhodesia, and Angola that can be understood only in terms of a change in the latitude of Africa. According to the official comment, they confirm the wide extent of cooler and wetter climatic conditions in South Africa, equating with the later part of the Worm or Wisconsin glaciation. Cool, wet weather in low latitudes is supposed to be contemporary with periods of glacial advance in glaciated areas. However, all of the dates fall within the limits of a short warm period within the Ice Age called the Denenkamp Interstadial, when ice sheets were presumably retreating. So how is this to be explained? It becomes understandable with a pole in Hudson Bay, because in that case, South Africa would be about 10 degrees farther south than now. That is nearer the South Pole, and therefore cooler, despite the interstadial.
Wait a minute. The South Africa would be further south when the pole was in Hudson Bay? That doesn't make sense.
That's what he's saying, yeah. Probably easier to see with a globe, huh?
I don't know. That's weird. Like you have to move the whole, you have to kind of roll the whole thing.
Yeah, you roll it, so this would be going, I don't know.
Yeah, I don't know. We need a globe.
Yeah. Part 7, evidence from Tasmania. Further support of our assumption is provided by some evidence used by Wegener to support his theory of drifting continents. He quoted the glaciologist Penck as saying that the Pleistocene snowline lay about 1,500 to 1,800 feet lower in Tasmania than in New Zealand, and added, "This is very difficult to understand because of the present nearly equal latitudes of these two localities." Wegener, of course, explained the matter by his theory of continental drift. If, however, his theory is rejected, displacement of the lithosphere may provide a solution, for if the Hudson Bay region was then located at the North Pole, as we suppose, Tasmania would have been a good many degrees nearer the South Pole than New Zealand, as a glance at the globe would make plain.
Yeah, dang it. I forgot to get the globe during the break.
Glancing at flat maps does not make this easy. Part 8. Confirmation from Antarctica. Powerful confirmation of another of the corollaries of a pole located in Hudson Bay comes from Antarctica. With the North Pole at 60 degrees north latitude and 83 degrees west longitude, the corresponding South Pole would have been located at 60 degrees south and 97 degrees east in the ocean off the Mac Robertson coast of Queen Maud Land in Antarctica. This would place the South Pole about 7 times farther away from the head of the Ross Sea in Antarctica than it is now. We should expect, then, that the Ross Sea would not have been glaciated at that time. We have confirmation of precisely this fact. During the Byrd expedition of 1947 through 1948, Dr. Jack Hugh, then of the University of Illinois, took 3 cores from the bottom of the ocean off the Ross Sea, and these were dated by the Ionium method of radioactive dating at the Carnegie Institution in Washington by Dr. W.D. Urey, who had been one of those to develop the method. The cores showed alternations of types of sediment. There was a coarse glacial sediment, as was to be expected, and finer sediment of semi-glacial type, but there were also layers of fine sediment typical of temperate climates. It was the sort of sediment that is carried down by rivers from ice-free continents. Here was a first surprise, then. Temperate conditions had evidently prevailed in Antarctica in the not-too-distant past. The sediment indicated that no fewer than 3 times during the Pleistocene epoch, a temperate climate had prevailed in the Ross Sea. So this is interesting. This is material that you might remember from Fingerprints of the Gods.
Yeah.
Graham Hancock brings this stuff up. So when this material that they found in the Ross Sea was dated by Urey, it was revealed that the most recent temperate period had been very recent indeed. In fact, it had ended only about 6,000 years ago. Hugh wrote, "The log of core N5 shows glacial marine sediment from the present to 6,000 years ago. From 6,000 to 15,000 years ago, the sediment is fine-grained with the exception of one granule at about 12,000 years ago. This suggests an absence of ice from the area during that period, except perhaps for a stray iceberg 12,000 years ago. Glacial marine sediment occurs from 15,000 to 29,500 years ago. Then there is a zone of fine-grained sediment from 30,000 to 40,000 years ago, again suggesting an absence of ice from the sea. From 40,000 to 133,000 years ago, there is glacial marine material divided into two zones of coarse and two zones of medium-grained texture." So yeah, I remember that clearly from Fingerprints of the Gods. He was talking about there's like this one granule that implies maybe an iceberg floated and dropped some stuff in the area where they were taking the core. But otherwise, from 6,000 to 15,000 years ago, there's fine-grained sediment off the coast of Antarctica, implying that at least some of it was ice-free. The period 133,000 to 173,000 years ago is represented by fine-grained sediment, approximately half of which is finely laminated. Isolated pebbles occur at 140,000 to 147,000 and 156,000 years. This zone is interpreted as recording a time during which the sea at this station was ice-free, except for a few stray icebergs, when these three pebbles were deposited. The laminated sediment may represent seasonal outwash from glacial ice on the Antarctic continent. So then, glacial marine sediment is present from 173,000 to 350,000 years ago, with some variation in texture. Laminated fine-grained sediment from 350,000 to 420,000 years ago may again represent rhythmic deposition of outwash from Antarctica in an ice-free sea. The bottom part of the core contains glacial marine sediment dated from 420,000 years to 460,000 years by extrapolation of the timescale from the younger parts of the core. So they didn't date couldn't date the earlier parts. They just extrapolated. So yeah, that's a lot of data, and it's basically the cores are giving you a huge time range. But it's interesting that in multiple places in the core, it basically implies that Antarctica has gone through full glaciation and then massive retreats of the ice over and over.
So going back to his explanation for the ice-free periods or whatever in the northern hemisphere, he was saying that his idea is that the pole shifted down to the Hudson Bay and then moved away from it and then moved back to it. I can't remember what he was.
It's moved a bunch of times. I don't know exactly where it's,
but it's not always going back and forth. It only goes to the Hudson Bay once. Right?
Well, it's interesting. He's so in the book, and if any of you guys have the book, you can see this figure 24. He shows the path of what he thinks the path of the South Pole is over the Antarctic area. Okay. So a long time ago it was out here, and then it moves across the pole basically and stops. And then it moves away from it again, and then it moves to its current position. So you can see that it's not a back and forth kind of motion. It's actually
starting to make like an hourglass shape.
Right.
Almost a figure eight or something.
Okay. So a comparison of the three cores shows that the end of the temperate period and the beginning of the most recent glacial period is well defined. That is, the cores are in close agreement. In Core 5 and Core 4, the change takes place 6,000 years ago. In Core 3, it is shown 1,000 years later than that. The next previous time when the three cores are in close agreement is 40,000 years ago, when the first two cores show change from glacial to temperate sediment. Core 3, again, is a little later, showing the change about 2,000 years afterward. Between the dates from 40,000 and 6,000 years ago, the sediment shows temperate climate in the Ross Sea, except for a period of 10,000 years of glacial deposition in Core 5, a very short period of glacial deposition in Core 4, and a somewhat longer glacial interval in Core 3. So here, as we see the cores are in disagreement, then it is possible that the differences are due to some disturbances at the bottom of the sediments. At any rate, it will be agreed that the evidence of the cores is more impressive when they agree than when they disagree. So all 3 cores were taken in deep water at depths of between 6,000 and 12,000 feet. Core 3, however, was taken further offshore, twice as far from the edge of the continental shelf. So whether this has anything to do with the slight time lag shown in it, I do not know. There seems at first nothing to show why Core 5 should have a longer period of glacial sediment interrupting the temperate phase than do the other cores. The cores are close enough together so that the same climatic conditions should have affected all 3 at the same time. So yeah, it's a little complicated, but he's just pointing out that the cores were taken relatively close to each other, but one of them, 3, was taken about twice as far offshore than the other 2. And core 3 is the one that shows, for some reason, later. It looks like things are happening later than the other cores. One geologist has suggested that perhaps the sediments in these cores do not represent regular deposition at all, but merely indicate the action of turbidity currents. Such currents are set in motion in the sea by slumping of sediments from the steep slope where the continental shelf ends. So basically like underwater landslides.
Yeah.
These sediments accumulate until they become unbalanced, or an earthquake or other disturbance starts a landslide, very much like an avalanche in the high mountains. Then the sediments from the shelf plunge down into the depths and are deposited on the deep ocean bottom. Turbidity currents appear to have been very active in arranging and rearranging the sediments on many areas of the ocean floors of the world. However, if a turbidity current has influenced the deposition in the core, the fact is shown by the arrangement or displacement of the materials. It has therefore been possible to check this question. I asked the specialists of the United States Geological Survey and also Dr. Hugh himself for their judgments on these cores, and their answer was that they saw no evidence of the action of turbidity currents.
Yeah, because you would imagine those sediments would be all jumbled up.
Right. Yeah. But
So if they're cleanly laid down, and you see the same patterns as you see in the
Right.
pristine cores, or what should be non-turbidity currents, then that would kind of disprove it.
Yes, and they say on these that they're, they're fine grained and they're well sorted. So
Yeah.
I like that he calls, he's like really checking this data. Okay. So another suggestion that has been made was that the warm period in the Ross Sea may represent the hypsothermal period, when the temperatures all over the world were a little warmer than now. This suggestion is not satisfactory because the hypsothermal phase began about 8,000 years ago and ended about 4,000 years ago. It lasted only about 4,000 years, while the warm period indicated in the cores lasted, though with interruptions, for about 34,000 years and ended when the hypsothermal was beginning. So that's weird. Like, why would somebody even try to use that as an explanation? A question has been raised about the reliability of the dating method used by Urey. However, the Soviet scientists have used this method with success, and Ericsson has found that the results obtained by the use of this method in deep-sea cores agree very well with comparable radiocarbon dates. We have observed the same thing in the cores already discussed. I had the opportunity to discuss the ionium method with Albert Einstein before his death, and he said he had studied the method and thought it reliable. There you go, just drop Einstein's name in there.
Yeah.
A possible explanation of the glacial deposition interrupting the long warm period in Core 5 is that the site of this core was nearest to the east coast of the Ross Sea, which is at that point about 200 miles distant. The massive Admiralty Range, with peaks up to 2 miles high, parallels this coast. And even at a time when the Ross Sea area might have been generally unglaciated, it is possible that the mountains would have had large glaciers descending to the sea and throwing off icebergs. The area would have been about 2,000 miles from the hypothetical South Pole. The mountains, then, would have been approximately in the latitude of 60 degrees south, similar to the north latitude of Hudson Bay. A mountain range 2 miles high at that latitude would probably be glaciated, and even if their glaciers did not reach the sea, rivers during spring thaws might have carried much ice. So accepting the cores at face value, we must realize that the date found by Urey for the beginning of the present glacial conditions in the Ross Sea is not the date of the beginning of the last change of climate in Antarctica. Rather, it was the end of the change, the establishment of present conditions. If our hypothesis is correct, the change took the same length of time as the whole period of the melting of the Wisconsin ice sheet in the northern hemisphere.
So what is he saying? To cool the Ross Sea took the same amount of time as it did to melt the northern hemisphere ice sheet?
Yeah.
Now, he's not talking about the Younger Dryas period, right, where it melts really quickly. He's talking about from the late glacial maximum down to the Holocene epoch?
So, yeah, that's a good question, because I have wondered about the Younger Dryas period. You know, because there's some stuff in here where he's talking about the melting of the North American and European ice sheets, and he seems to indicate that it happened quickly, but I'm not sure it was clear at the time how quickly it took place. Yeah. I don't know. But yeah, I think he thinks it was catastrophic, but how catastrophic? But I guess the main point he's making here is that the current conditions in Antarctica are sort of timed with the current setup of conditions in North America. You had to melt all this ice, while as in Antarctica, you had to build it up.
Okay.
But yeah, what the question you asked, I don't know.
It's like it. I think like what Randall is talking about, and I could be wrong, but I think he's saying like it may have taken a couple of thousand years.
Sure.
To melt all that. Now the ice would have been dead ice.
Yeah. Stagnant.
After the end of the Younger Dryas.
Yeah.
So it wasn't building back up, and it wasn't, but it's just sitting there and slowly melting.
Right.
A bunch of it did catastrophically melt all at once.
Right.
Or in a couple of weeks to produce the flooding.
Then you have who knows how many cubic miles of just stagnant dead ice left over, still melting down.
While the new poles, according to Hapgood, are starting to freeze and accumulate.
Right.
Yeah.
Yeah.
New zones of accumulation.
Right.
Okay.
Next is part 9. He goes into some maps, ancient maps.
Maps.
A little bit of maps.
All right, we'll be right back.
Yeah. Snacks. The Snake Bros Institute for Advanced Coprolite Studies, where there are no degrees, only certificates of ignorance that you have to make yourself. And yes, we had an emailer last episode, Troy, who wanted to have doctorates of ignorance, but there are no degrees, my friend. I'm sorry. It was a fantastic and hilarious idea, but there are no degrees.
Thank you for the email, doctor.
That's right.
I mean,
he's certified. But he doesn't have a doctorate. There are no degrees.
And there's no board either, so you can't be board certified.
So Kyle has brought in the globe.
And we have confirmed.
It's now standing before us, this fake sphere.
South Africa would move south.
Yes. It would kind of do a little curl down there towards the south.
It's a conspiracy. The flat maps don't make it look like it could not be.
So speaking of maps, part 9, the evidence of an ancient map. It is rare, says Hapgood, that geological investigations receive important confirmation from archaeology. Yet, in this case, it seems that this matter of the deglaciation of the Ross Sea can be confirmed by an old map that has somehow survived for many thousands of years. A group of ancient maps, including this one, was the subject of an entire book which I published in 1966 under the title Maps of the Ancient Sea Kings. In some way or another, which is still not and may never be entirely clear, this extraordinary deglacial map of Antarctica has come down to us. Apparently, originated by some ancient people unknown, preserved perhaps by Minoans, Phoenicians, and Greeks, it was discovered and published in 1531 by the French geographer Oronteus Finaeus. Maybe. That's how you say it. I know it's the Oronteus Finaeus map.
Yeah.
But I don't know how to say his actual name. And it is part of his map of the world. Impossible. This would be the opinion of practical people of intelligence and learning. Utterly impossible. But sometimes truth is really strange. It has been possible to establish the authenticity of this ancient map. In several years of research, the projection of this ancient map was worked out, and it was found to have been drawn on a sophisticated map projection with the use of spherical trigonometry, and to be so scientific that over 50 locations on the Antarctic continent have been found to be located on it with an accuracy that was not attained by modern cartographic science until the 19th century. And, of course, when this map was first published in 1531, nothing at all was known of Antarctica. The continent was not discovered in modern times until about 1818 and was not fully mapped until after 1920.
That's amazing. Wasn't it Hapgood that in the book of the ancient sea king, the maps of the ancient sea kings, somebody has a classroom of guys.
That was him, yeah.
That was Hapgood, right?
I think
He's
so,
teaching
yeah.
this class and they're doing cartography or whatever, and he's like, so we're going to have to strip away all the layers of this map to figure out what projection they were using to get this coastline.
That's right. So he has a picture of the Oronteus Finaeus map in here, and then he compares it to a bunch of modern maps of Antarctica, and then he has a table which shows the 50 different locations that are correlated. He says this table should be compared with the map in Figure 28, which is the Oronteus Finaeus map, with a modern grid worked out by my students and myself at Keene State College in about 7 years of research.
Yes. God, that's awesome.
The serious student should obtain a large modern map of Antarctica, either that produced by the National Geographic Society or the more elaborate and up-to-date map produced by the American Geographic Society. With the large map, he should follow the coast, comparing it with the Oronteus Finaeus map and this table, and he will conclude, I am sure, that the agreement of the ancient and modern maps is entirely beyond the probabilities of coincidence. In evaluating the errors on the map, the reader should allow about 60 miles per degree of latitude, but he should remember that the degree of longitude is very short in the high latitudes, diminishing to 0 at the poles. As a result, the longitudes on this map average out as accurately as latitudes. And then he has a huge table here of all the basic agreements of a modern map with the Oronteus Finaeus map with the latitude and longitudes of the 50 different or 58 different locations in Antarctica, and he shows the errors they're all very small, within a degree or two. Well, let's see, the biggest...
Which could be due to crustal shift, maybe.
Maybe,
I wonder if they're all in the same direction.
Yeah.
Maybe not.
Well, some of them are bigger. His 4-degree east error, 8 degrees west. But it's really interesting because, he's saying that the disagreement would get larger.
Yeah, east and west is the longitude.
Yeah.
That's...
So, there's a whole huge list here of all these places that basically agree with the Oronteus Finaeus map. So, in final comment on this extraordinary evidence, I will say that though this map is proved to have existed as far back as 1531, no map of this accuracy could have been drawn in modern times until the invention of the chronometer in the reign of King George III at about the year 1780. This instrument first made possible the accurate determination of longitude. If this were not all so completely proved, it would, of course, sound like a fairy tale. Statistics, however, do not lie. the mathematical probabilities of anyone accidentally getting so many points right on a map are fewer than 1 in 100 million. This is good evidence for the displacement of the lithosphere. Okay, part 10, confirmation from South America. Support for the assumption of the pole in Hudson Bay comes also from South America. That assumption involves the southward movement of both North and South America at the end of the Ice Age. The southward movement of southern South America would result in its climate becoming not warmer, but colder at the end of the Northern Ice Age. Evidence of this has unexpectedly been furnished by Dr. Calvin Hoosier of the American Geographical Society in the course of presenting a paper to an international symposium on world climate. During the discussion after the presentation of the paper, Hoosier remarked that the first known Argentine glacial advance had been dated at about 350 BC. He further stated, however, that there were indications of cooling of the climate in Argentina between 6,500 and 4,500 years ago, just when the warmer hypsothermal climatic phase was setting in Europe and other parts of the world. He thought that this cooling might have caused glacial expansion at that time in Argentina. The contrast between this story and the events in Europe and America will be apparent to the reader, so let us recapitulate. We have two areas lying at similar distances from their respective poles. In one, the northern, we have many evidences of heavy glaciation extending over a period of perhaps 40,000 years, but ending about 14,000 years ago, to give way to the present climate about 10,000 years ago. So see, that right there where he says this heavy glaciation ended 14,000 years ago, that's the beginning of the Younger Dryas.
Yeah. That's Meltwater Pulse 1A.
Yeah. So I just wonder if all this is before that was really made clear. In
other words,
in
his
scientific
research.
Yeah. Like maybe they hadn't fully identified that extremely short period of the Younger Dryas at this point. In Chile and Argentina, on the other hand, in the same relative latitude, just as close, presumably, to a pole, we have no glaciation until after the climate has become normal for the present temperate zone in the north. It appears that in Argentina, a cool period set in just as the hypsothermal phase with higher temperatures set in all over the northern hemisphere. Clearly, then, there was no similarity in climatic trends, but rather the opposite. Argentina and Chile grew colder when they should have grown warmer. This supports the assumption of a crustal shift moving the western hemisphere southward toward the Antarctic Circle. To sum up, the evidence for the proposition that the North Pole really was located in Hudson Bay during the Wisconsin glaciation is very strong indeed. A great deal of additional evidence will be found scattered through other chapters in this book, especially in Chapter 10, which goes into the question of the extinction of the mammoths. Part 11, the relationship of the Wisconsin ice cap with the glaciations in Europe and Alaska. So our assumption of a pole in Hudson Bay confronts us with the problem of explaining why, with that location of the pole, there was a glaciation in Europe, the northern part of which would have been farther from the pole than it is now. And the same problem arises with Alaska. Why, during the Ice Age, did Alaska have many mountain glaciers but no continuous ice sheet? The explanation of the glaciation of northwestern Europe is, I think, as follows. First, the heaviest glaciation of Europe was not contemporary with the Wisconsin ice sheet, but was the consequence of an earlier pole position, which will be discussed farther on. Secondly, the comparatively thin European ice sheet of Wisconsin time, which in Britain really consisted only of discontinuous mountain glaciers, was made possible by a very special combination of meteorological conditions. In North America, a vast ice cap extended eastward from its center near Hudson Bay. Much of the continental shelf in this whole area was then above sea level and was covered in ice. Then, anticyclonic winds blowing outward in all directions from the ice cap had only to cross the narrow North Atlantic, raising moisture from the sea and depositing it upon Scandinavia and Britain. So far as the glaciation of Alaska is concerned, again, the climate there was colder than it is now because of the vast refrigerating effect of the ice cap that covered 4 million square miles of the continent. Just as at present, the Antarctic ice cap makes the South Polar region colder than the Arctic because it is a perfect reflector of the sun's radiant energy back into space. So then the Great Wisconsin ice cap meant that the prevailing temperatures at the center of this ice sheet were much lower than the temperatures prevailing at the present North Pole. So I think he's talking about because the ice sheet was so much more massive, because it was over land at this time, that it had a much greater effect on the climates of stuff surrounding it than the current North Pole, which is the ice cap is much smaller because it's over water. So he says the present North Pole where no great ice cap exists. But although the intensely cold anticyclonic winds blowing off the Wisconsin ice cap made Alaska colder than it is now and thereby produced larger glaciers than exist at present, still, these winds blew only over continuous land, not over the sea, and so they could not pick up the moisture required to produce a continuous ice sheet. This explains why Alaska warmed up at the end of the North American Ice Age, even though it actually may have moved closer to the pole. The displacement of the Earth's surface layers would necessarily have implied a great deal of disturbance on the Earth's surface in addition to climatic change. The turbulence accompanying the polar shift is the subject of the next chapter.
All right.
So I'm not sure about that. I'm not sure I like that explanation there at the end of that chapter.
Which part?
The thing about Alaska. He's saying, okay, so because everywhere else in the book we're saying like, wow, so if you rotate the globe so that the pole is in Hudson Bay, then we see a basic rough correlation with things that move closer to the equator get warmer, things that move farther from the equator get cooler. But then he's struggling with like, well, how do we explain the massive European ice sheet if you rotate the pole, and all of Europe should have gotten closer to the equator and thus warmer. So his answer to that first is, well, that massive ice sheet in Europe was thinner. It wasn't as big as the one in North America, and he thinks it's actually the remnants of a previous pole position ice cap. So that's interesting. But then the part about Alaska, I mean, it is interesting that he's saying, okay, so you have this massive amount of wind, it's blowing across all this ice, it's going over Alaska, it makes Alaska colder than it is now, but at the same time, it doesn't pick up any moisture because it doesn't go over any ocean, so it doesn't drop a lot of snow there and allow accumulation. So I was confused with it. I thought Alaska, at least parts of Alaska, were warmer during the Ice Age than they are now, not colder. I don't know.
Or just had less glaciers, maybe?
Yeah. But isn't there evidence of... I think he's going to go into this later, so it's probably I just don't understand what he's talking about, is what's going on. Because I think that, some of this is, how do you explain these areas where mammoths lived having flowers and stuff like that?
Yeah. I don't know.
Okay, Chapter 5. The Violent Life of the Last Great Ice Sheet. Part 1. The Acceleration of Erosion and Its Cause. So it goes without saying that the geological effects of a polar shift would be many and varied. Some of them will be hard to imagine, much less reconstruct. Others may be suggested in a general way, and for still others, definite evidence may be presented. There is good evidence that some geological processes were accelerated during the Ice Age. There was greater precipitation of rain or snow. There were more violent or rapid processes of erosion and deposition of sediment. For such a deviation from natural conditions, it is important to pinpoint a cause, if we can. First, however, it is important to present the evidence. It is all the more important to do this since many geologists have tended to ignore it, and those who have observed the evidence have been unable to account for it. David B. Erickson and other oceanographers have repeatedly pointed to evidence of this accelerated rate of sedimentation of the Ice Age. On one occasion, Erickson wrote, "Decrease of turbidity current activity with amelioration of climate and rise of sea level towards the close of the Wisconsin glacial stage, is indicated by the decrease in the number and thickness of graded layers in the upper parts of most marine sediment cores. It is inferred that the Pleistocene epoch and the glacial stages were times of exceptionally rapid sediment accumulation. So this is another one where when I read this, I wonder if that's idea is changing now, because it
of the Younger Dryas floods.
Yeah, it seems like this would be an example of where they're just assuming that all this is a gradual process, right? In other words, it's spread out over all this time, but now it's much more like, okay, we know that there were these immense meltwater pulses that deposited a whole bunch of stuff all at once very quickly. But I think what they're talking about here is that during the entire ice age, you just had generally accelerated erosive processes, but it's probably now more thought that a lot of that erosion happened very fast, catastrophically speaking, Okay, so in another paper, Erickson wrote, radiocarbon age determinations show that the rate of sediment accumulation in the equatorial region varies from 2.2 centimeters per thousand years to 4.3 centimeters per thousand years. It is at least suggestive that the rapid rate of accumulation took place during the latter part of the Wisconsin time. A similar relationship, though in less degree, is found in one core from the Caribbean. 2 radiocarbon dates of samples from cores taken in the Chukchi Sea, Alaska, suggest the same thing. This series permits estimate of the rate of sediment accumulation in this area. If derived ages can be considered valid, then data show a remarkable decrease of sediment accumulation during the past 10 to 12,000 years. So again, right now, we don't have nearly as much sediment accumulation in the ocean cores as they did in the periods before. But the way he was talking about this, like, well, it's 4.3 centimeters per thousand years, but is he just spreading out?
Right.
I don't know.
He's saying radiocarbon dates, though.
Yeah.
I mean, if
yes. Yeah. The radiocarbon dates of these samples from the cores in Alaska.
But apparently, I mean, during that glacial period, you would have these, in the summers and when it's melting at the edges, you would have huge outburst floods and all kinds of stuff happening all the time. So maybe it is a more erosive environment.
I think it was in general, yeah. I agree. And Hapgood is also seeming to imply that it was just more catastrophic, because you have to have the period too where the whole crust is moving.
Yeah.
So from France, we have the following statement relating to a series of radiocarbon dates of the glacial period made on samples from a core taken in the Mediterranean. Ages found for sections 43 to 51 centimeters and 51 to 59 centimeters are too old because they contain much reworked carbonate, which probably indicates that after the end of the last glacial period, a very important erosion period occurred in southeastern France. And from Australia, we have evidence that the turbulence of climate was worldwide. A radiocarbon date from the Goulburn River in Victoria produced this comment. Channel geometry of streams which deposited silts indicates higher discharges than in present hydrological regimes. And from California, we have the suggestion of much heavier rainfall than at present. Flora represents a pinyon juniper woodland like that now in the San Rafael Mountains, a few tens of miles to the southwest, and indicates 10 to 15 inches more precipitation than today per year, I think is what they're saying. One writer...
Yeah, so this would be probably, I'm just guessing that's sort of in the area of the Lake Bonneville Basin.
Oh, yeah.
That's a huge basin. So there was a regime of like this steady rainfall that was coming in that was keeping that lake full.
Yeah.
Maintained at its level for so long, and then right at the end of the Younger Dryas, or somewhere in the Younger Dryas period, it catastrophically rained and overfilled it.
Right.
Which
and then it overflowed.
Which cut down the side of it.
Yeah.
Wherever the outflow part was. And then after that, there was never enough rainfall to even keep the lake full at its normal level, and it just slowly evaporated, and now it's the Great Salt Puddle.
Yeah, that's right. The Great Salt Puddle.
I mean, it is like compared to what the lake was.
Yeah.
But I'm assuming that's what he's talking about there, because that whatever that climate regime was bringing all that moisture up.
Yeah.
Into that place that's now basically a desert.
Yes. So one writer, Leland Horberg, assembled much evidence detailing the same thing by comparing the rates of retreat of the ice sheets as shown by radiocarbon dates with present known rates of ice movement. Horberg believed that the radiocarbon dating method must be wrong because it led to impossibly rapid processes of erosion and sedimentation in the Ice Age. The radiocarbon method, however, has been very well tested and is now considered highly accurate, although mistakes are made now and then with this method, as with all others. But Horberg has collected and studied the radiocarbon dates bearing on the history of the Wisconsin ice cap. He summarizes its short and violent history as follows. A. The first appearance of the ice sheet in Ohio is dated to about 25,000 years ago, although it had probably been advancing from its center in the Hudson Bay area for 20,000 or 25,000 years before that. This advance of the ice sheet into Ohio is called the Farmdale Advance. It was formerly thought to have occurred as much as 100,000 or even 150,000 years ago. This date, then, cuts the time for the later history of the ice sheet by about 3/4. 6 different radiocarbon dates, all of the Farmdale Advance, show that the expansion continued until at least 22,900 years ago, or for about 3,000 years. And then there was an unexplained interval of warm climate called the Farmdale-Iowan Interstadial. This warm period lasted about 1,500 years, during which the ice withdrew a certain distance.
See, now those types of things you could attribute to just solar activity or something like that, right?
Yep.
Volcanism, I don't know.
Yeah, but
volcanism would be easier to find the evidence for, but
yeah.
Solar activity, I mean, that would not be so easy.
Right. Need to do some geology on the sun.
Yeah, we need to take some sun cores.
Sun cores.
You just poke through the outside and your core would just fall into emptiness.
What's interesting though about this guy Horberg, and Hapgood is going through with this guy's information is Horberg just seems to have a problem with
it happening too fast.
Too fast, yeah. He's just like, nope, this is impossible by the uniformitarian.
Carbon dates are wrong.
Yeah, because uniformitarianism is right.
Yeah.
So B, following the recession, the Farmdale-Iowan Interstadial, a new advance of the ice cap occurred. This is referred to as the Iowan Advance. It began about 21,400 years ago, lasted 700 years, and was interrupted by a new recession about 20,700 years ago. C. This second recession, after less than 1,000 years, was succeeded by an extremely massive advance during the period from 19,980 years to 18,050 years ago. These dates must not be taken as exact. There is always a small margin of error. This new expansion, called the Tazewell Advance, apparently carried the Wisconsin ice cap to its maximum extension. D. The Tazewell Advance was interrupted by a prolonged period of warmth and recession called the Brady Interval, or the Brady Interstadial. This lasted about 3,000 years. It began before 16,720 years ago and ended sometime after 14,042 years ago. The ice retreated a long way. E. A fourth advance of the ice sheet beginning about 13,600 years ago and continuing to about 12,120 years ago, called the Carey Advance, was followed by the Two Creeks Interstadial, an interval of warmth and recession, about 11,404 years ago.
Okay. So that they don't have the Younger Dryas period yet.
Right.
So those dates have been revised to 12,008, right, and 11,6.
Probably, yeah. But then he has a fifth advance of the ice, referred to as the Mankato Advance, appears to have taken place between 10,856,000 years ago, or 10,856,000 years ago, and 8,200 years ago. The high point of this advance is called the Mankato Maximum. Another writer, Emiliani, finds that a sixth expansion of the ice sheet called the Cochrane Advance took place less than 7,000 years ago. So I wonder how much, this is still, I would love to look this up.
I do remember hearing something about something going on around 8,000, 8,000 years ago that was also pretty catastrophic.
Yeah. G, there was a sudden, virtually complete disappearance of the ice sheet, which had, however, according to Flint, been getting thinner ever since the Tazewell Advance. H, shortly after the disappearance of the last of the ice, there was a period of warm climate, which was actually warmer than the climate today. This is called the hypsothermal, or sometimes the climatic optimum. It lasted from 8,000 years ago to about 4,000 years ago. According to Brooks, the temperature then averaged about 5 degrees centigrade warmer than now. There is, at present, no accepted explanation of this warm period. Compared with the usual geological time concepts, even the period of 10,000 years for the decline of the ice sheet from the end of the Tazewell Advance is incredibly rapid. Horberg, as I have mentioned, has pointed out that if the radiocarbon method is valid, the rate at which the ice must have advanced and retreated indicates that geological processes, that is, meteorological processes like rainfall, must have been greatly accelerated during the Ice Age. Now it is easy to show that these processes inevitably would have been accelerated by a movement of the crust, and we shall return to this matter below. Another line of evidence suggesting an acceleration of the rate of geological change is presented by Emiliani, who has applied a technique of determining ancient temperatures of seawater developed by Harold C. Urey. Urey's method is based on the use of an isotope of oxygen. Emiliani has noted many important temperature changes in a comparatively short period during the latter part of the Pleistocene, and he has reached the conclusion that the 4 known Pleistocene ice ages all occurred in the last 300,000 years, and he agrees essentially with Horberg as to the date of the beginning of the Wisconsin. So, assuming the radiocarbon dates to be correct then, we find that at the end of the Tazewell Advance, there was a recession, and that despite the re-advances, the ice gradually thinned until the ice sheet disappeared. This can be accounted for by the assumption that the crust was in motion, and that it continued to move slowly during all or most of the 10,000 years during which the ice cap was in intermittent decline. As I have already pointed out, there is no other reasonable explanation for the disappearance of the ice sheet. Which I think is, there are reasonable explanations for it now. But it's interesting. So if he's correct...
But he's still talking about a gradual shift over 20,000 years almost, right?
Yeah, the 10,000 year long recession 10, of the ice sheet after the Tazewell Advance,
which is 25,000 years ago or whatever.
Yeah.
Which we talk about it in terms of the late glacial maximum.
Yeah.
25,000 years roughly.
Yeah.
So he's thinking that it migrates slowly over that whole period down to basically the start of the Holocene.
Yeah.
Or is he talking about it going all the way to the climatic optimum?
Yeah, I think he's basically
it's still moving in the climatic optimum.
That was just that was just the list that he got from Horberg.
Yeah. Okay. I'm just trying to figure out when it stopped moving.
Right. I don't know, and he hasn't really given a precise. I think the last I remember he was saying that the pole, the last movement of the pole, coincides with the basic end of the last ice age or the beginning of the Holocene period, is what he said.
Yeah. Okay.
So,
all right.
I don't know. I just think it's interesting. Like, we do have a different explanation now for the disappearance of the ice, but that explanation, the comet impact thing, doesn't explain the placement of the ice off of the pole.
Right.
So, is there a way to combine these things, and are they connected somehow?
Yeah, are they connected? Yeah. Was this...
Because, the end of the Younger Dryas is still a mystery, right?
Right.
So, does Hapgood's explanation explain that. Like the Comet Impact or the Comet Research Group is saying the beginning of the Younger Dryas is started by some kind of mass bombardment, airbursts and other things actually impacting.
And you get the crust vibrating.
Then the crust starts to move. And you have a whole, then you have the buildup of the black mat layer because everything's in motion, stuff is catastrophic. Ice builds up all over the place, but then the pole basically finishes moving to its current place, and then the ice starts melting again after everything calms down.
Yeah, that's cool.
All right. I think
How much more you got on that chapter?
What, this chapter?
A lot.
Yeah, we just started this chapter.
All right, well, we'll finish chapter 5 next show. All right, folks, we'll be right back.
We will be right back.
And we're back, ladies and gentlemen. Snake Bros, end of show rants, emails, space weather news. I don't think we got any stories. I do have a story, actually.
Oh, you do?
I do. Just remembered. But yeah, time to let the old hair down, buddy. You don't have hair to let down. I'll do it.
I have some hair.
I'll do it for both of us.
Well, I do have crypto. Bitcoin. We haven't done crypto in a while. Bitcoin is $19,202.93.
Still
and
hanging
Ethereum
out.
is $1,319.
Still hanging out in around 20K.
20K, yeah. Yep.
Cool.
What about the old, what if folks want to know all the behind the scenes? A little behind the scenes?
Well, we decided to do a little extra bonus for you guys today, just to kind of give you a little idea of how the brilliant content on this show is actually created.
Yeah, how is it that we come up with these amazing shows every week?
So yeah, here's a little segment of behind the scenes.
Snake Bros, behind the scenes.
So, what do you want to do for the next show?
I don't know. I've been thinking about it, looking at. I don't know. I mean, should we do like Hamlet's Mill?
I've got a great idea, dude.
Okay.
Göbekli Tepe.
Didn't we just do?
The Vulture Stone, bro. The Vulture Stone.
Okay.
The Vulture and the Scorpion.
Okay.
It's the desert and the sky. It's a new angle. It's like the pyramids are in the desert beneath the sky.
Well, I mean, isn't the vulture kind of also a desert?
No! Dude, you're not getting what I'm saying.
Okay.
The vulture in the sky is the pyramids, bro.
Oh.
That is a perfect subject for the next episode. All you got to do is a bunch of research, figure it out. You'll get it. I know you will, because it's a brilliant idea. And then you can come and give a presentation on that idea. Okay. It'll be a great show.
Okay, so I'm supposed to do the research on
You're the talking guy. You're the one who does all the stuff. I come up with the great ideas. You do a 2-hour show on it. It's genius.
Well, this is like the first time that you've come up with any ideas. Is that really what you're supposed to do?
Oh, boy.
I mean, is that really what happens?
Are you getting snappy with me?
I'm not. I'm sorry.
You know, I come up with all the good episodes, and you do a good job.
Okay, look, you did a great job on Epic of Gilgamesh, but that was like 3 years ago.
I only did that because you couldn't come up with anything. So I came up with something to save you.
I was tired that day.
Are you tired right now?
Then
let's do Göbekli Tepe,
all right.
It's genius.
Okay, all right. I'll do some research. Can you send me some YouTube links?
Oh, God. I'll have to do the research for the YouTube.
I mean, yeah.
All right.
Cool.
I'll save your ass.
I appreciate
Again. We're geniuses.
Snake Bros behind the scenes.
Brought to you by Pyramids, the only way to build pyramids.
So there you go. Little behind the scenes for you guys.
We got a new supporter. Wait a minute. What do you call it when you get an advertiser?
A sponsor?
A sponsor.
Pyramids.
Yes. Pyramids is our new sponsor.
The only way
It's
to
the
build pyramids.
only way. So we'll have to figure out how that works.
So yeah, no ag, no rock and roll update really. I mean, I guess the only rock and roll update is we're practicing again to play that.
Yeah, we're playing a little
acoustic show.
like a small festival put on by a large group of friends.
Yeah. So
yeah.
we've been working on that.
You gonna do space
Weather News?
Alrighty.
From spaceweather.com. Lucy flyby update. NASA's Lucy spacecraft flew past Earth today, so close that it skimmed the upper atmosphere. So far, no sightings have been reported, despite the spacecraft being as bright as a first magnitude star over Australia and visible through telescopes in the western USA. And the sun just swallowed a comet. On October 15th, Soho coronagraphs caught a Kreutz sun grazer diving into the sun just as a bright CME was leaving. Kreutz sun grazers are fragments from the breakup of a single giant comet many centuries ago. They get their name from German astronomer Heinrich Kreutz, who studied them in detail in the 19th century. Kreutz fragments pass by the sun and disintegrate almost every day. Most, measuring less than a few meters across, are too small to see, but occasionally a bigger fragment like this one attracts attention. The CME was not caused by the comet. It was hurled into space by a magnetic filament eruption in the sun's southern hemisphere while the comet was still far away. NOAA analysts have modeled this CME and determined that it will not hit Earth. So I did find that interesting. So we have wondered about, could comet fragments impacting the sun actually cause solar activity? And I was like, ooh, the CME right over the comet, but Space Weather News says
Nope.
No correlation. Current conditions, solar wind speed is 538.7 kilometers per second. The density is 10.35 protons per cubic centimeter. Sunspot number is 50. Neutron count is 2.5% above the space age average, and the KP index is 3, which is quiet. And the 24-hour max was 4, which is the low end of the unsettled range. And that is your Space Weather News for the week.
Thank you, Russ. Mm-hmm. And from NASA. This, when is this story? October 4th, 2022. Collision may have formed the moon in mere hours. Simulations reveal.
It's only a model.
Oh, I did see some of this.
Billions of years ago, a version of our Earth that looks very different than the one we live on today was hit by an object about the size of Mars called Theia, Theia, which is a little bit like Tiamat. Tiamat. Theia. And out of that collision, the moon was formed. How exactly that formation occurred is a scientific puzzle researchers have studied for decades without a conclusive answer. Most theories claim the moon formed out of the debris of this collision, coalescing in orbit over months or years. A new simulation puts forth a different theory. the moon may have formed immediately in a matter of hours when material from the Earth and Theia was launched directly into orbit after the impact. This opens up a whole new range of possible starting places for the moon's evolution, said Jacob Kegeris, a postdoctoral researcher at NASA's Ames Research Center in California's Silicon Valley and lead author of the paper on these results published in the Astrophysical Journal Letters. We went into this project not knowing exactly what the outcomes of these high-resolution simulations would be. Yes, I would imagine. So, on top of the big eye-opener that standard resolutions can give you misleading answers, it was extra exciting that the new results could include a tantalizingly moon-like satellite in orbit. The simulations used in this research are some of the most detailed of their kind, operating at the highest resolution of any simulation run to study the moon's origins or other giant impacts. This extra computational power showed that lower resolution simulations can miss out on important aspects of these kinds of collisions, allowing researchers to see new behaviors emerge in a way previous studies just could not see. Understanding the moon's origins requires using what we know about the moon, our knowledge of its mass, orbit, and the precise analysis of lunar rock samples, and coming up with scenarios that could lead to what we see today. Previously, prevailing theories could explain some aspects of the moon's properties quite well, such as its mass and orbit, but with some major caveats. One outstanding mystery has been why the composition of the moon is so similar to Earth's. Scientists can study the composition of a material based on its isotopic signature, a chemical clue to how and where an object was created. The lunar samples scientists have been able to study in labs show very similar isotopic signatures to rocks from Earth, unlike rocks from Mars or elsewhere in the solar system. This makes it likely that much of the material that makes up the moon originally came from Earth. In previous scenarios where Theia sprayed out into orbit and mixed with only a little material from Earth, it's less likely we'd see such strong similarities. Unless Theia was also isotopically similar to Earth, an unlikely coincidence. In this theory, more Earth material is used to create the moon, particularly its outer layers, which could help to explain this similarity in composition. There have been other theories proposed to explain these similarities in composition, such as the Synestia model, where the moon is formed inside a swirl of vaporized rock from the collision, but these arguably struggle to explain the moon's current orbit. This faster single-stage formation theory offers a cleaner and more elegant explanation for both these outstanding issues. It could also give new ways to find answers for other unsolved mysteries. This scenario can put the moon into a wide orbit with an interior that isn't fully molten, potentially explaining properties like the moon's tilted orbit and thin crust, making it one of the most enticing explanations for the moon's origins yet. Getting closer to confirming which of these theories is correct will require analysis of future lunar samples brought back to Earth for study from NASA's future Artemis missions. As scientists gain access to samples from other parts of the moon and from deeper beneath the moon's surface, they will be able to compare how real-world data matches up to these simulated scenarios and what they indicate about how the moon has evolved over its billions of years of history. Beyond simply learning more about the moon, these studies can bring us closer to understanding how our own Earth became the life-harboring world it is today. The more we learn about how the moon came to be, the more we discover about the evolution of our own Earth, said Vincent Eek, a researcher at Durham University and a co-author on the paper. Their histories are intertwined and could be echoed in the stories of other planets changed by similar or very different collisions. The cosmos is filled with collisions. Impacts are an essential part of how planetary bodies form and evolve. On Earth, we know that the impact with Theia and other changes throughout its history are part of how it was able to gather the materials necessary for life. The better scientists can simulate and analyze what's at play in these collisions, the more prepared we are to understand how a planet could evolve to be habitable like our own Earth. And there is a video of the supercomputer simulation and it's actually really cool with terrible music. but so it
shows a liquid state,
yes,
right?
it's like this liquid state, and these two bodies collide, and a giant mass comes off, and there's a collision of the mass that's thrown off of the Earth.
Yeah.
And a piece of that drops a little droplet out, and then the biggest part of the mass that flew off falls back to the Earth, leaving this little droplet way out there in a stable orbit. Like the gravity of the big plume that came off the Earth kind of slows that, or sort of slingshots that little droplet out there, and then slows it down and like puts it into this stable orbit. So
okay,
yeah. Seems more like a spaceship to me, but this model is pretty cool to look at, so go check it out at nasa.gov.
Cool.
That's all I got.
All right. Shall we tackle some emails then?
Yeah, let's do it.
Okay.
Let's talk to these folks.
Yeah. This first one is from Paul. Paul has written in several times. It says, it's called Heading to Texas Soon. Hello, Snake Bros. This is Paul from Northwest Ohio again. I'm writing because my family trip to Texas is just around the corner. I'm not sure if you'll be around between the 7th and 10th of November, since I know you were going to Egypt around that time, but if you are, that would be badass. I heard on your latest cast that $50 Dynasty is doing a concert on the 5th when I will only be as far as Arkansas, so maybe you could play really loud so I can hear it from there. I'm totally bummed to be missing that one by just one day, though. If we're unable to meet up, no worries. I have a few questions about some sites in your area. Is the museum in Bandera worth a look? I think so. I mean, it's fun.
Yeah. Hey, dude, they got a
little natural history museum there is cool.
They got a big old bone in there that's 20,000 years old that has like
tool marks on it. Yeah. And what about Stonehenge? The Stonehenge in Kerrville. Stonehenge 2?
I haven't even ever been there.
I haven't either. But you should go check it out.
Lame? Like we just don't. That's lame. We need to go check that out.
Give us a report. Yeah. Also, I see the orchard you work at offers tours. Is November a good month for that? My wife and I love trying the local wines from the places we travel, so we are definitely going to Turtle Creek Winery in Kerrville. My kids love looking for fossils in arrowheads, so is there a public area for doing that in your area? I have far too many questions to put in this email, so I'm going to stop now before you think I'm a lunatic. You guys are awesome. Snakes! From Paul.
Thanks, bro. Hey, man, it's always a good time to go by the vineyard. It's beautiful, but it'll probably be... It won't be very green, I would imagine, at that point.
The vines are starting to go dormant as we speak, but they're turning yellow.
It's still beautiful property.
Yeah.
But
you can definitely go to the winery in Kerrville. You can talk to them there about getting a tour.
As for looking for fossils and artifacts, I don't know of a public place.
Public place, right?
Yeah.
I don't know.
But if you go to some of the state parks, I mean, you can... There's fossils everywhere.
Yeah.
So there'll be like you know what a lot of people do? On the highway, like 173 between Bandera and Kerrville.
Oh, yeah, there's
some
road
big
cuts.
road cuts.
Yep.
And people pull over there and just kind of like climb up those sort of whitish, caliche hillsides, and there's always fossil beds in there. It's a lot of fun. The kids would probably dig that too.
Yeah. And aren't there some state parks out here that have dinosaur footprints? And was that Government Canyon?
Government Canyon.
Yeah, Government Canyon has prints. So yeah, I don't know about looking for arrowheads though.
Yeah, you're not supposed to do that.
Yeah, you're kind of not. Yeah.
Just look for them, but don't pick them up. That's what we do.
That's right, Kyle.
Yes, Russ. You have affirmed what I am saying is true.
I affirm what you're saying.
Clyde?
Nope.
What am I looking
Brandon.
for? Oh, okay. Brandon writes to us, and he says, The Quest for Knowledge and Ignorance Certificates. He says, hey there, Kyle and Russ. I apologize now for the long read.
Yeah.
Well, you are forgiven.
It is a tome.
First things first, I want to thank you both for such a great collection of edutainment that's kept fresh with your fantastic sense of humor. Monty Python fans for the win. And never ceases to keep me coming back for more. Thanks, bro.
What, behind the rabbit?
No.
I'm just throwing in some Monty Python.
It keeps him coming back for more. What?
What, behind the rabbit?
The previous comments truly resonate with me when stating that this is one of the best podcasts out there about these widely varied and seemingly heavily correlated subjects.
Oh, thank you.
After discovering that Napoleon did not establish the original meter and other significant history-changing coincidences, BAM documentaries, for example, I couldn't keep from trying to find out what the heck was going on. I've been a skirptard for most of my life, and after revisiting the subject of these mysteries, particularly concerning the apparent impossibility of megalithic structures, it pulled me down a rabbit hole filled with a wonderland of information that all eerily seems to correlate.
Yes.
That's very cool. In traditionally practiced science, significant data is needed to generate a foundation for understanding. When that information correlates to a certain level, we can use logic to find patterns in the data. With the amount of coincidences that seem to be proposed by modern science, and after trying to make sense of their dismissal of relevant data, I couldn't help but get legitimately angry. It makes it feel like someone you've trusted your whole life has been blatantly lying to you about specific things all along. Took a good amount of time to make it through all 260 episodes, but I enjoyed every second of it. I must commend you both on your oratory skills, as the ability to listen to YouTube at increased playback speeds has helped tremendously with getting caught up in record time. Man, I bet that bumper music sounds pretty nuts.
Yeah.
I will be re-listening to a few really great sods till the next and have caught up on the Cosmographia conversation as well. Phineas's letter was one of the craziest things I ever heard.
Yeah. Isn't that the guy from the burning episodes, that letter? Is that what he's talking about?
I'm not sure what you're talking about. I don't think I know what he's talking about.
On Cosmo, the letter that Randall read, that was the report from the guy.
Oh, yeah, from the
I
Chicago
think that's
fires.
what he's talking about, yeah.
Yeah. So he goes on to say, I love how you both get along so well and are openly willing to challenge your understanding of the existence we reside in, despite our limited perception of that existence. It is so difficult to find people willing to talk about these things without completely saturating it with their biases or inconclusive assumptions driven by dogmatic views. This inevitably results in the abstaining of the sharing of ideas, which is unfortunate since, in my honest opinion, that's how we truly figure things out. Now that I have completed my briefing of the prerequisite information, I can finally get all the jokes and understand the conversation and the references made therein. Since that milestone has finally been reached and these eyes can finally readdress my original understandings, I decided to commemorate my completion with my own forged certificate of ignorance.
Yes.
And I need to look at... Okay. He included it for our critique and consideration.
Yeah, it's a great look.
He says, I hope you like it, and I'll post it in the Discord as well. Make sure you get that awesome fossil face pegged so that if you glad, you can keep future generations of researchers enthralled by your stony visage. Keep up all the great work. Snakes! P.S. Going to look into getting some of your wine as I'm inclined to partake on occasion. P.P.S. Decided to merge the Cosmo and Bots logos in the certificate since you're hosts in both, and they really go hand in hand when exploring the subject. Cool. So let me look at this.
Yeah,
Let me see.
it is a very excellent and professional looking certificate.
Wow.
Yeah.
Johnson.
Yeah. Johnson is one of the is the head of logistics.
Yes, this is great. Dude, this is awesome.
Yeah.
You even put a soccer ball in there for the watcher. No, I'm just kidding. It's a dodecahedron. I know what it is, oh boy.
Yeah,
He's got the five
Cosmographia gear with the Ouroboros from Brothers of the Serpent in there.
Yep. He has the Fibonacci sequence represented in the squares, the rectangles and squares.
Got a cube and
and the tetrahedron.
Mm-hmm.
This looks very solid.
Yeah. That is a solid. Oh, and there. What is that in the background? That's a old school labyrinth.
Oh.
Yeah.
Hey, we're on opposite sides of the labyrinth there. This is great, dude.
Yeah.
I love it. We'll have to get it printed on some good, solid cardstock so that we can write our names in crayons.
This certificate is to recognize, due to 1, unresolved logical fallacies and assumptions which are relentlessly opposed by the standard model of science. 2, surprisingly large amounts of unaccepted yet significantly correlative and relevant data being dismissed through either indoctrination, negligence, or corruption. And 3, the vigilant resistance of modern academia to modify its effective approach to scientific analysis to obtain more logically feasible, understood, and accurate results. This verifies that even with the additional 30% brain expansion provided by the Institute of Advanced Coprolite Studies, that blank is wrong at least 99% of the time concerning the deeper complexities, inner workings, or histories of our known existence. This individual is fully aware of this fact, and though they may seem resistant at times, are eager to shed the skin of their past understandings to increase the probability of making more accurate statements regarding these subjects.
That's great. This such and such is wrong at least 99% of the time.
That's right. That's great. Fantastic.
Awesome.
Excellent certificate there.
Logistics is John.
Yes. Chief of Logistics.
Okay. Who's next? We gonna do one more?
We'll do one more. I got a short one here from Graf Buttflapperheimer von Schland. Hey, Slytherins. Your podcast lightens up my day. If I listen to one of your episodes several times, they are still good. They don't expire. The best before date on your product is Frog Wiggling Eternity. Marty does such a great job that I started looking into monster trucks. I found a picture of possibly the very first monster truck. If you could forward this to Marty, I would thank you. And he's got a picture here that says, on this day in history in 1927, Ricky Dale Everclear becomes the first man to put oversized rims on his truck with his girlfriend's tax return. Look at those.
Yeah.
Sincerely, from Graf Buttflapperheimer von Schland.
That's great. Oh, man. We appreciate it, guys.
Yeah.
We do some more? Or are we done?
No, I think that's it. The next
We're
one is
rolling it up.
another tome.
Yeah, but it's the legend
It
of
is the
episode
legend
one.
of episode 1. It's very long, though.
Gosh. I want to know about this legend.
Thank you guys so much. If you want to email us, brothersoftheserpent@gmail.com. That's how you get a hold of us. I do read all the emails. Can't read them all on the show, but we always appreciate the emails. Really do. And it's great fun to read them on the show and respond.
Yeah.
Website, brothersoftheserpent.com. It's got all the podcast-related stuff, including the pyramid scheme, which is how you can support the show. We use the value for value model, so if you get any value out of the show and you want to return that value, you can do that through Patreon or PayPal. If you do, between 50 and 100, you're associate executive producer of that episode. 100 and above, executive producer. So that always helps through PayPal, or you can join the Patreon through monthly donations and get Patreon content.
That's right.
Which includes bumper episodes, extra, basically long segments that we do after. Sorry, not bumper episodes, bumper music. I've been slowly adding all the bumper music to the Patreon. And there's videos on there and other stuff. So join the Patreon or donate through PayPal and support the show. And we really appreciate everybody who's doing that. Thank you guys so much. It really helps.
I want to make Paul Haslinger, Haslinger. Paul. I'm not sure how to pronounce your last name, old boy.
Traveling Paul from Northwest
Traveling
Ohio.
Paul, but we're going to make you executive producer of the show because I was looking through your history on PayPal and you have donated beyond $100 to the show. So we really appreciate that.
There we go.
So you are the executive producer of this show. And I don't even know what the number is, but it's like 163 maybe.
So donate to the show. Elsewhere on the website, you can also find the way to get into the Discord if you want to talk with like-minded serpents. You got to pass a test. It's not too hard. If you listen to some episodes, you should be able to pass the test. And then you can get into the Discord and talk with other serpents and maybe make some meetups. People have been meeting up with each other in different areas around the world and going to look at snaky stuff. So that's cool. And yeah, I think that's it for this week. Thank you guys so much. We love you.
Always have.
Always will.
Good night, Adamu.
Get back to work.